All right, so yeah, let's use the other formula now. So remember, the other formula is the slope of the tangent line is equal to the limit as h approaches 0 of f of a plus h minus f of h, or minus f of a, excuse me, all over h, right? And so we know that a is 3, right? So what we're going to do is we're going to plug in, if I want to find the slope of the tangent line at a, then what I'm going to do is I'm going to plug in 3 for a, if I want to find the slope of the tangent line at 3, I should say. Right? So we already know f of 3, right? We just did that before, so we know this is 9, right? And now we just have to evaluate f of 3 plus h. Okay, so that's going to be 3 plus h squared. And so if I were to FOIL that out, 3 plus h times itself, 3 plus h, we would get 9 plus 6h when we combine like terms, plus h squared. And I'm just going to turn that around and make it h squared plus 6h plus 9, right? And just kind of put it in standard form. So that's what I'm going to put in here for this. So when we rewrite this, it'll be h squared plus 6h plus 9 minus 9 all over h. Okay, and we can see what will happen is these 9s will cancel out when we combine like terms, and so we'll end up with h squared plus 6h over h. Right? And so here we want to try to factor if we can, and we see that we have a common factor here, right, in the numerator of h. So what I can do is I can rewrite this as h times h plus 6, right, if I factor out a h from here, all over h. And so then we can see that these h's cancel out, right? And that gets us to the point where we can directly evaluate at 0, right? Before we couldn't plug in 0 because we get a 0 in the denominator. But now that we just canceled out the denominator, we realize that we have a removable discontinuity at 0. And so we can just input 0 into h plus 6, which gives us 0 plus 6. And we end up with 6, right? The same result as we had before. So that just shows you the two different formulas, yield the same answer, just different ways to get there, right? So, all right. And there'll be times when you're asked to use one or the other, but yeah, either way is the same. Now let's go back to the last problem because it actually says find the equation of the tangent line, right? Find the equation of the line tangent at 3. So we know that either way, we know when our input is 3, our output is 9, right? We found that f of 3 equals 9, right? We plugged in 3 and we got 9. And so we know that, and we now know that the slope of the tangent line, either way we find it, is 6, right? And so now we can use our point slope formula to say, okay, well, it's going to be y minus y1 or y naught equals m times x minus x1 or x naught. Okay, so we can say y minus 9, get the 9 from right there, equals m, which is 6, times x minus 3. Okay, and that's fine. That you can just leave it like that. That's the equation of the tangent line. If we were to simplify, we could distribute the 6, and we could get it to slope-intercept form. We would get 6x minus 18, and then we could add 9 to both sides. So if we needed to graph this, we could get it to slope-intercept form, and that would maybe make it a little bit easier to graph, where we had the y-intercept is -9 and the slope is 6. But it's okay to leave it like this. All right. So just to give you a visual, This function that we start out with, f of x equals x squared, is a parabola, right? And so we can see that that's the kind of the red or orange line. And what we just found is we found the slope at that particular point, right, which is 6. And then we found the equation of the tangent line, which is y equals 6x minus 9, okay? So we can see that as a y-intercept of -9 and a slope of positive 6. So it's going up and to the right at a rate of 6/1, okay? All right, so that kind of gives you a visual of what we just did. And so instead of finding the average rate of change or the slope between 2 points, we actually found the slope at an individual point using limits.